Hello, I am Shivakar Nayak, lecturer in Polymer Technology Department of Karnataka Government Polytechnic, Mangalore. On behalf of Department of Collegiate and Technical Education, I am going to present on the topic injection molding. This is related to the Unit 1 of the course Plastic Processing Technology for the third semester. Program is Polymer Technology. The course outcome is the student will understand the basic concept of injection molding process. In my today's session, we are going to discuss about the topics like theory of injection molding and various components of injection molding machine, injection unit, feed system, screw and barrel, etc. The screw design, nozzle and processing parameters. And at the end of my session, multiple choice questions and answers will be there. So let us begin. Now the first unit, it comprises the plastic injection molding. Injection molding is one of the processing techniques of plastic raw materials. We can manufacture different types of parts or products by these techniques. So what are the raw materials we can make use? Of course, we can make use thermoplastics and thermoset materials. What is the advantage of this process? We can manufacture simple to very complex type of products with variable cross sections at the lower cost. At the cheaper cost we can manufacture. How it is made? Plastic is melted and it is then injected into the mold which gives the shape to the material. Molten plastic is injected at high pressure into the mold, which is the inverse shape of the mold. The mold is made from metal, usually by steel. This process is widely used for manufacture of variety of products, smallest components to entire body of the cars. Big panels of cars, etc. can be manufactured. Injection molding is a process for producing the parts by injecting the molten material into the mold. It is a plastics equivalent of metal die casting. Most widely used method for mass production. If you want to produce a product in multiple numbers, this method is the cheapest, very ideal, and we are going to get the good quality products of the same dimension. So three-dimensional articles over the wide range of sizes and varieties of shapes can be produced. Simplest to complicated parts or components even can be produced by this method. Different types of raw materials in the shape of powders, granules, we can make use. See, in this diagram, you can see a machine. This is called injection molding machine. This is a hopper, feed hopper it is called, into which the raw material is fed. And here there is a horizontal barrel, nothing but it is a cylindrical shaped one, hollow cylinder like, it is placed horizontally, and inside of this there is a well designed screw which is a rotating one. When the screw rotates, the material from the hopper, it will be getting into the flights of the screw, and it will be going to advance, and it will be moving to the exit end, that is to the this end. This entire unit, what you can see over here, this is one of the main part of the machine, that is called injection unit. This end is called hopper end. The other end is called as nozzle end. So here there is a control panel. Settings are available in this. And here we are going to fix the mold, and the rear, this part is a locking unit. So injection unit, mold and locking unit. These are the three main components of this machine. And this is the, of course, the control panel. From entire machine is controlled by this panel. And there are number of heaters provided on this barrel in order to melt the plastic material which you are going to place into the hopper. A cross-sectional view of this machine is shown over here. This is the hopper, which is, you can see this one, cut section of the hopper. Here from here to here, this is the barrel. You can see from here to here, this is the barrel. And this is the arrangement to push the raw material into the mold. So this is the arrangement, hydraulic cylinder, hydraulic, by means of hydraulic pressure, this material is pushed into this mold. This is the mold. Two halves of the mold you can see over here. This is this portion, this depicted here. These are the tie bars to hold the mold together. This is the arrangement. This you can see over here. These are the tie bars, front side, back side, top. There are 4 numbers which is visible here, 2 numbers. And this is the locking unit. This is the body of the machine. These are the number of heaters here, which is covered here, but it is shown by this cross lines. So heaters, the feed hopper, hydraulic motor and gears, hydraulic pump, and the barrel and nozzle. This is the end of this barrel is called nozzle, and these are the mold holes, and these are the tie bars, and this is a clamping unit or locking unit. These are the main parts of the injection molding machine. This is a pictorial view. This is the cross-sectional view of the injection molding machine. Now, what are the raw materials you can make use for this injection molding process? A list of materials is shown here. First is ABS. ABS stands for acrylonitrile butadiene styrene. Acetal polymer, acrylic polymer, polycarbonates, polyesters, polyethylene, fluoroplastics, polyamide, nylon, polyphenylene oxide, polyphenylene, polystyrene, polysulfone, polyvinyl chloride. These materials are available in semi-crystalline or amorphous form. Some of these are available in the filled form. Filled in the sense we are going to incorporate some of the ingredients. for better processing or for giving the aesthetic look, etc. Now I am going to discuss about the injection molding process. Just now we have come across the what is injection molding machine. The machine is meant for manufacture of different process by the by making use of heat and pressure, and we make use different thermoplastics and thermosets as raw materials. Injection process is conducted in two ways. One is by reciprocating screw. Inside the barrel there is a well designed screw which is fitted inside the barrel, which is having the action of reciprocating action, and this reciprocating screw will melt or plasticize the raw material, and it will push the material further. The melted plastics will be injected into the closed mold via the channel system that is called runner, gates and runner. Cools the mold, refills the material for next cycle. The cooling of the mold is also done in the machine. Refilling of the material for the next cycle is also carried out. Next, after the cooling of the mold, the product is ejected and the mold is going to close for further cycle. So, in injection molding, raw material is melted or plasticized inside the screw barrel arrangement. Molten material is injected into the closed mold. Mold is closed. Refilling of the material for the next cycle takes place. Ejection of the product after cooling, and then followed with the mold close for the next cycle. Now, what is cycle? Cycle is nothing but repetition of certain things. The time required for one complete cycle is shown over here in the pie chart. Say the filling of the mold takes place here. Before that, number one is close, mold close. Closing of the mold is done. Two halves of the mold comes together and they will be held at high pressure by the locking unit, and into the closed mold the filling of the material takes place. The molten plastic material is filled into the closed mold. This is further from 1 to 5, that is the time wise it is written. Next, it minimum of 5 seconds it will take place, and around 10 seconds it will be held together, and the molten material will be in the mold under pressure, which is completely filled. The molten material is completely filled into the mold, and the mold after cooling, the cooling time starts from here to here, approximately 15 to 18 seconds takes place. Is the longest duration that is in the cycle, that is for cooling. Mold cooling is done. So because of that, inside the whatever the product is there, that is also become cooled. Then from here to here, around 2 to 3 seconds, that time is meant for ejection, that is the removal of the product from the mold. Then now the mold is open and the product is removed. So next comes this complete from here to 1 to 35, what is mentioned over here, this makes a one complete cycle. So mold closing time is very least. So mold comes, joins, and it will be held under pressure. Filling of the molten material takes place, and the molten material is held at a certain pressure for 10 seconds. Then it is the cooling period starts approximately 15 to 18 seconds, and for after cooling the mold is opened, product is removed out of the mold. This complete cycle takes around maximum within the 40 to 50 seconds, not more than 1 minute it will not take. And of course the product size, if it is bigger, of course a little more time it may take. product is smaller and less wall thickness, lesser time is sufficient. What are different types of injection molding machines? Of course, there are three different versions of the machines available. This is a hand operated injection molding machine, that is the very smallest and the cheapest machine, which is meant for producing very small components. Next type, this is a plunger type injection molding machine. In this machine, there will be a barrel with the plunger arrangement, and all other parts of the machine will be the same, like hopper, heaters on the barrel, then mold closing unit and the mold, all are required. But only the difference, only thing is this in this type of machine, plunger is used to push the material to the exit end of the barrel, thereby due to the pressure as well as from the heat supplied by the heaters provided on the barrel, that will be going to affect on the material. Material will be melted completely, and when the plunger, when it reciprocates and when it pushes the material, that material will be going to fill into the mold. So that way it works. In plunger type machine, barrel is placed horizontally, whereas in hand operated machine, barrel is placed vertically. Next type of machine, this is the advanced type of machine, that is the reciprocating screw type injection molding machine. All are these injection molding machines only, but how they have been designed, what are the size of the product they can be manufactured. So accordingly this being classified. Small products are produced by this machine, that is the hand operated injection molding machine. Little bigger and if not sophisticated, such type of products are produced by plunger type machine, and this is the, of course, not the advanced machine. And this type of machine, that is a reciprocating screw type injection molding machine, is a well advanced machine, and you can produce very beautiful products with a large size, with good dimensional accuracy, finishing, etc. So in this type, there is a screw inside the barrel which is meant for melting the material and to take the material in forward direction in order to fill the material, molten material, into the closed mold. Screw is a reciprocating one. When the screw moves back, the refilling of the raw material takes place, and when it moves in forward direction, it is a rotates and moves further. When injection is to be done, then it pushes the material. Instead of revolving, it acts like a plunger. So it acts like both plunger as well as that action, reciprocating action will be there again. It will be going to revolve also. When the material is to be melted, it revolves. When material is to be filled, it acts as a plunger type, and it comes back, refilling of that material takes place. So that way it is going to work. Now let me discuss about injection molding machine of smaller version, that is shown over in these diagrams. This is the pictorial view and this is the cross-sectional view. See here, this is the barrel and this is the hopper, feed hopper, and this is the nozzle. Here barrel is placed vertically and it is fitted to the body of machine. And see here, you can see barrel is here, it is fitted, and this top portion, this is rack and pinion arrangement. In this rack and pinion arrangement, there is a plunger is fitted. When you rotate these levers, 1, 2, 3 levers in clockwise direction, this will be moving downwards. The plunger will act downwards and it will exert pressure over here. The material is placed into the barrel. You have to feed it from the hopper. After filling completely or to the little, about 1 inch, leaving some gap. So you have to rotate this by means of lever, so that this plunger will go and act over the material in downward direction due to the pressure. And the heat is supplied here from the outside. The band heater is provided around the barrel. So due to the pressure and heat, both are important. Heat is to melt the material, pressure is to fill the mold. Here the mold is placed. Mold, one part of the one hull of the mold is fitted here, another hull of the machine is fitted here to this end of this lever. When you rotate this clockwise, this will be going to close the mold. When you rotate this anti-clockwise, this moves backward direction. So mold closing is done by this, as well as mold opening. This can be done by this lever, and the material is filled into the mold by means of this lever, which is attached to the rack and pinion arrangement. This is shown over here, and this is the electrical supply given to the heater provided over the barrel, and these are the lever to close the mold and to open the mold. Now this has a vertical barrel and plunger arrangement. Band heaters are there. Energy regulators is regulator is provided. So whatever the temperature you need, according to the type of machine, type of raw material, you have to set the temperature. And torpedo and nozzle arrangement is there. Nozzle arrangement you can see over here. There is a small opening at the exit end of the barrel, and here there is a torpedo. Torpedo is nothing but a metallic object. It is fitted at this end so that material has some restriction to flow at the pressure, so that unmelted material even can be melted by means of that arrangement. Now let us discuss about plunger type of injection molding machine. See here in this diagram, you can see a machine of bigger size, which is having a horizontal barrel and a hopper arrangement. In this machine, both this type of machines, vertical as well as horizontal type, is available, but most of the machines have horizontal type of barrel. Now in a horizontal type of machine, we have ram type injection molding machine and a screw type injection molding machine. In this diagram you can see the ram type of machine. See, this is the feed hopper, material is filled here. This is the barrel. So inside the barrel there is a ram. So ram is going to push in this direction. When the material will falling here, in the meantime this is going to push, the ram is going to push the material, will be pushed to this end. Here there is a torpedo which will be useful to spread the material. Unmelted material even can be melted, because the passage is very least here. Due to the squeezing effect, the material will be completely melted, and that will be going to fill into the closed mold, which is shown over here. This is the clamping unit of the machine. Now in injection molding, the resin is fed from a hopper into the barrel and heated through thermal energy. Thermal energy sense, electrical supply is provided to the band heater. The heater is heated to the desired temperature. Because of that heat, the material will be going to melt. The molten resin is collected into the pool in the barrel, that is at the exit end, so that whenever the mold is closed, you can fill this melted material into the mold. The molten material is pushed by the action of plunger, that is the ram type or piston type we call. So for better mixing the molten resin, this pushing action is required. So here at the exit end there is a unit called a torpedo or it is also called as a spreader. This will spread the machine because the space available for the passage of molten material is very least. Hence, that material is squeezed properly, unmelted granules even going to melt properly here in the torpedo section. Then in the after that it will be going to the unmelted material melt, and this molten material will be pushed into the mold that is in the closed position. Now in front of the section, in front section, sufficient length to be provided for to accumulate the melt. So before it advances into the machine, that is the mold, this should be there for certain time so that it will be melted properly. What are the advantages of this machine? This type of machine is the best run for marbleized structure material such as plastic wall, etc. But more sophisticated and the discrete parts cannot be produced by this RAM type of machine. The RAM type machine, there will be sometimes a leakage of material and the color will not be mixed properly. Pressure drop will be there and poor shot control. We cannot adjust the proper shot weight and difficulty in running the heat sensitive materials. Heat sensitive material in the sense some materials are very sensitive to heat. When you heat more, then the color fading, overheating of the material takes place, degradation of the material takes place. If you heat less, then it will not melt properly and it will cause certain problem during the production, and the product we will not be able to get of the good quality. Here you can watch the cross-sectional view of a machine that is having two stages. This is the horizontally placed machine barrel. Say in this in the top there is one more arrangement that is called a plasticizing chamber. Material is fed from here and it is going to fall here, and the ram is going to push the material. Torpedo is in here in the middle and the molten material is going to move here, and one more here arrangement is there. Then this material will be going to push by this and mold will be on this side. So these are the two stages shown. This when the ram is backward and the material is just fed into the chamber, and next in this step you can see the ram has ram, or here screw can also be used. So screw is advanced, it's moving, rotating, and the material is taken to the other end. From here it is going to accumulate by the plunger. It is pushed into the closed mold. Now we can let us discuss now what is the two-stage plunger type machine. In our previous slide we have seen one extra arrangement is there for say melting the material, that is for plasticizing unit, and one more separate unit will be there, that is the injection unit. So both one more extra plasticizing unit is incorporated so that the capacity of the machine can be increased, efficiency improved, quality can be improved by this kind of combination. Next, the two-stage plunger machines are replaced by two-stage screw type machines. The injection shot is the same as a plunger type, but screw type machines are better than plunger type of machines because the uniformity will be there in the mixed molten material. Cold run type of material with the design improvement can also be incorporated in the injection plunger type of machine, or you can preheat the material and you can place into the feed hopper. Now let us discuss about the reciprocating screw type injection molding machine. This is a more advanced machine and it has a feed zone, compression zone and metering zone. The entire barrel of the machine is divided into three zones. First is the charging of the material, what we call feed zone. Next comes the compression zone. Next comes the metering zone. So compression zone is also called a transition zone. So these three zones, let us see in this. You can see over here. See, this is the feed end. What you call here, feed hopper is provided. Material is charged from here, and this is a barrel, and red in red color shown is barrels. Sorry, number of heaters. And inside the barrel there is a screw which is a revolving one at constant speed. And you can see over here the molds fitted to the two platens. These are the robust or strongly built type of mold, as well as this kind of play mold platens. This is a nozzle, and this is a screw and screw bush through which the molten material is pushed into the cavity of the mold. So now let me tell you let me show what are the three zones available here. This first half of the total length from here to here is a feed zone. Next comes the transition zone, that is the middle zone, and this exit end, there is a metering zone. So the entire length from here feed end to the exit end, this is divided into two equal, that is the first half is the feed zone and second half is divided into again two, transition zone and metering zone. Now what are the different components of this advanced type of screw type of injection molding machine? Here you can watch, see, this is the important part. It is like a mouth, or it is a feed hopper from which we charge the material into the machine. Next, below this, that is the throat of the machine, and here some arrangement is there to control the feed. And here there is a barrel arrangement. Onto the barrel there are number of heaters. These are the heaters. This is the first heater, second heater, third heater, and so on. This screw is a rotating one as well as a reciprocating one. To and fro motion will be there. This is very essential for melting the material and rotating. When mold is closed, rotating action will be stopped, and the screw is going to reciprocate. It will push the material in order to fill the material into the mold, and it will be moving backward. So reciprocating action will be there, as well as rotating action will also be there to this screw. Now here you can see the plate parts, machinery, stationary plate, and this is not a movable one. This is a movable plate, and in order to open the mold, this is moved this end, so that these two molds, two halves of the mold will be get separated. This shaded portion is the molded product. This is called nozzle. Here screw. These are the various components of an injection molding machine. Now we are at the end of the session. Let us discuss now about what you have learned in this today's session by some asking some questions. Multiple choice questions are here. First question is: injection molding process is most widely used method of dash production. This method is very popular in plastic industry. Many number of plastic products are produced by this process. So, how many methods? Then I mean to say the products of single products is manufactured, multi products are manufactured, all mass production is done here in this machine. All of these cannot be the answer. The correct answer is This machine is meant for mass production. Now question number 2, which is not a part of injection unit. Injection unit is the major part of the injection molding machine. See, some of the parts are given here: feed hopper, barrel, heaters. Of course, these are the parts of injection unit. But mold is a different one. These are not the part of the injection unit. So the answer for question number 2 is mold. Now what is the question number 3? Question number 3 is, in injection molding, products are made in finished state. Is it true or false? True, of course. Whatever the product you produce by injection molding technique will be going to get the product in the finished form. Next question number 4. The capital cost of injection molding machine is dash compared to other molding machines. See, the machine, since it is more sophisticated and it is having higher capacity to melt the material, higher output, so hence capital cost of the machine will be quite high. So the answer to the question number 4 is high. Now question number 5. Hand injection molding machine is useful to produce dash products. Small products, very big products, big, any size. Of course, the machine is a very smaller one. Only few grams of the material can be charged into, say about up to 25, 30 or maximum 50 grams of material only can be fed into the machine. Hence, of course, we cannot manufacture very big as well as big products. Only the small components can be produced by this machine, hand injection molding machine. Now, let me discuss about the question number 6. The output of injection molding machine is dash. Output is very high because the machine is very sophisticated and the capacity, melting capacity is very high. So output will be very high for injection molding machines. Question number 7. Modern injection molding machine has well designed plunger, screw, both plunger and screw, none of these. Plunger type of machine is a older version. Now the newly developed is a screw type of injection molding machine. So the answer to this question number 7 is screw. Raw materials for injection molding is a dash. So here thermoplastics, thermosets, both of these, none of these. These are the answers given. Of course, in most of the machines we can process thermoplastics, but some specially designed machines are available in which we can make use the thermoset raw material even. So answer to the question number 8 is both of these. That means thermoplastics and thermosets both can be processed. The mold for, next question number 9. The mold for injection molding machine is constructed by using aluminium, steel, wood, POP. POP is nothing but plaster of Paris. Of course, the machine is very strongly built because more greater injection pressure is required, and hence the mold should be very stronger. Of course, aluminum cannot be used, of wood and POP also cannot be used. The correct answer to the question number 9 is steel. Now question number 10. Molten plastic is injected at a dash into the mold, which is the inverse of the desired shape. Molten plastic in the sense a melted plastic. It is injected into the mold under high pressure, low pressure, no pressure. See, if there is no pressure, material will not be filled into the mold. If it is pressure is low, under low pressure also, mold will not be completely filled. So high pressure is a must to fill the mold completely so that the product of good quality, of course, you can produce. Thank you.